Hello everyone. Welcome to Semaphore Uncut, a show where we talk about engineering topics, products, and people behind those products. My name is Darko, and I'm your host today. I'm co-founder of Semaphore, and today with us we have Charity Majors, who is joining us live. So, hello, Charity. Nice to have you.
Hi,
Nice to have you on the show.
thanks for
And
having me.
please go ahead and introduce yourself.
I'm the co-founder of Honeycomb, currently CTO. I was CEO for 3 long years until recently. And we are a company that is an observability product that helps you understand what's actually happening on these crazy complex systems that we keep inflicting on the universe without having to ship new code to handle, things that we know of in advance.
hmm Okay, and maybe before diving deep in the technical topics, I can ask a bit more about Honeycomb and the product.
Yeah,
Uh,
yeah. So Honeycomb was started. It came out of my co-founder Christine and I were both early engineers at Parse, the mobile backend as a service. Love Parse, rest in peace. And we were acquired by Facebook in 2015. And around the time we got acquired by Facebook, I was coming to the horrified realization that we had built a system that was basically undebuggable by some of the best engineers in the world doing all of the right things. And yet every day people were coming to us, like, Parse is down. And I'd be like, Parse is not down. Like, behold my wall full of dashboards. Like, they're all great. Like, everything's cool, right? Because maybe we're doing 100,000 requests per second. Mobile app traffic isn't huge. Maybe they're doing like 50 requests per second or 4, right? Never even show up in my time series graphs. So I'd have to dispatch engineer or go debug myself exactly what had gone wrong, or if it was their fault or our fault or some combination of the two, or codependency problems, like someone else was starving them of resources and their shard, or their, just like it would literally take a day sometimes or more to figure out what was actually going wrong in each case. And like our productivity ground to a halt. Like we stopped shipping when we were just trying to understand our product. And I tried everything out there. The problem with logs is that you have to know what to search for before, and if it's a new problem, you don't know what to search for. And the problem with metrics is they aggregate at right time and you can't break down by high cardinality dimensions, like say user ID, right? So it was a very manual and awful process. The first thing that helped us start to dig our way out of this pit was this tool at Facebook called Scuba, which is not a pretty tool. I would go so far as to say it's actively hostile to users. But it did one thing really well, which was it let you slice and dice in basically real time on dimensions of arbitrarily high cardinality. And cardinality meaning like, the number of unique elements in a set. So like the highest possible cardinality will always be in a unique ID, right? First name, last name, high cardinality. Gender is low cardinality, and species is very low, I assume, right? So like solutions didn't support that, and we started getting our data into this tool at Scuba, and it started to drop our time to understand these complex scenarios that just dropped like a rock, like from days to like seconds, like maybe a minute. But it was like a support problem, not even an engineering problem. Um, this made a huge impact on me to the point where I was leaving Facebook, planning to go be an engineering manager at Slack or Stripe, and suddenly realized, oh shit, like I no longer know how to engineer without this code, the stuff that we've written and we built around Scuba, because it's not just about incident response. It's like my five senses. Like it's how I know what I'm doing. It's how I decide what to build by like instrumenting something, looking at the impact, what it's going to affect, and then I write it. And as I'm rolling it out, I have this constant conversation with my code, just like, is it doing what I thought it would do? Is it behaving as I expected? Does anything else look weird? And the idea of going back to like metrics and logs was just, it was unthinkable. Like it felt back to like using ed instead of like an actual editor, right? So, but at the time we thought that this was a platform problem. Like Christine and I started working on this for a year, and we really thought that this was a platform problem because platforms all have this characteristic where like it's one of many thousands of apps to me, right? But to you, like it's your world, right? It's everything. And then beyond that, like to your users, you have tens of thousands of users, but to you, it's like they're all kind of undifferentiated. And we're like, well, all platforms have this characteristic, and so maybe the tooling just isn't addressing that need. And over the course of the first year, as we started talking to users, we started hearing, first of all, the anger in their voice. They were not happy with their solutions, and because it wasn't solving their needs, right? They wrote a big check because it was supposed to solve their problems, and it did for a while. But then they would need to answer a very basic question like, okay, all of this, but for one user, just for the user that's complaining, right? And we started to realize that this is just a function of pure complexity, and our systems are skyrocketing in complexity. It's like some of this is self-induced, but like, whether it's containers or schedulers, polyglot persistence, the proliferation of mobile devices, all of these things are high cardinality problems, and everybody needs a different solution. And so as out of this, observability was kind of born, because I was reading the Wikipedia page for observability, and I realized that, every term in data is overloaded. But observability, according to the control theory definition, was just the ability to understand what's going on in the inner workings of a system just by observing it from the outside, not by knowing in advance, writing custom code to handle it, not by any of these things that work for known unknowns, but it's really about action such that you can ask any question of your systems and without having to ship custom code to handle that. And this was kind of like a mind-blowing thing to me, because it really spoke to the shift from known unknowns, which we had in the days of the LAMP stack, right, to unknown unknowns, which on the distributed systems of today, it's like the problems we have to deal with are like this infinitely long, thin tail of things that almost never happen. And it's not a good use of our time and effort to invest in a dashboard that'll make us find this problem immediately the next time, or a monitoring check. We're handling all these things as one-offs, like there's some end in sight, and there's just not. So that was kind of the original insight that led to Honeycomb, and also to us taking a pretty aggressive stance that this was something different, and that observability is something that the industry needs to know and respect as a technical term, not just as a generic synonym for telemetry. And I've gotten a lot of flack over the last couple of years about, it's a marketing term. And like, okay, so it's a marketing term. Maybe, I don't know. I think of it as a technical term because you can look at a tool and just say, does this give me observability or does it not? And if it does pre-aggregation, it doesn't give you observability because you're baked into, you've gathered your data in a way that prohibits you from asking any question, right? Same with indexes. Same with, you need to be able to do read time aggregation of the raw data in order to have that flexibility. So anybody who's not offering that is not doing observability. So I think that the reason it's taken off is because so many people have seen themselves and their problems reflected in this distinction. Mm-hmm. I'll pause for a breath here.
Okay, yeah. Yeah, it's a interesting journey, and definitely in the area of like scratching your own itch. So
yes. Oh God, yes.
Yeah, so it that's when people get really motivated when it's something.
Yeah, and the thing is that like this comes at the right time, I think, because there are a lot of other trends that aren't strictly speaking like observability related, but it turns out they kind of are, right? Like the rise of like it's just in the past 3 years, I feel like we've really arrived at a consensus that software engineers need to be on call for their own systems, right? This was not an accepted answer 3 years ago, but we've learned as an industry that this is the build these systems and support them in a way that scales, in a way that is not miserable for the humans who have to tend them, right? And so the person who has the original intent, what they're trying to build in their head, goes and watches it all the way out to where your code is interacting in real time with users, right? And you're the only person who knows really what you're expecting to see. You have to like take it all that way. You can't just lob it over the wall. You can't just say my job is done when I've merged to master, right? The ops team doesn't have your original intent, right? And you don't have, necessarily their skill sets. So I feel like this is kind of the second coming of DevOps in a way. Like the first wave of DevOps is all about ops people must learn to write code. And like, yeah, absolutely, like message received. And we do now, right? But like the second wave is very much about, okay, software engineers, like it's your turn. It's time to learn to write operable services, and it's time to learn to run them, because that's, and I'm not saying that all roles are going to dissolve and go away, but like operational expertise is increasingly almost a niche consulting area of expertise where we're here to help you as software engineers run your own services using our expertise, not to do it for you, because that is the direction in which lays like misery and pages waking up every night. And like a lot of people are really afraid that being on call means that that's what I'm asking them to do. And I want to be clear that it's not, right? I'm over 30. I don't want to get woken up in the middle of the night either. But the thing is that we can make it so that no one has to get woken up if that person with original intent is babysitting it all the way to the end, and if we just raise our standards for what we accept and you know, in terms of the abuse that we're willing to sign up for as engineers.
Great. So to explain it to myself, some of the things that you shared, and hopefully for some of the customers, some of our viewers that are watching also. So with generally observability and what you mentioned about metrics and logs. The problems that we have with metrics and logs, that we must decide to emit them. So we must benchmark certain part of code, and okay, this was not benchmarked. Let's introduce these metrics. Let's put it on some dashboard somewhere, and let's wait for data until we have enough data. And with logs, it's very similar. So it's usually that process. So we have a bug. What's the best thing to do? And if something is really complicated, let's add a couple of lines of logs and wait for the next. Next iteration. So we are doing that, so we would want to get away from that problem of like having to, because as you said, we cannot figure out in advance what measurements.
So it's fundamentally reactive.
Exactly.
You're always reacting to something.
Okay.
Yeah.
And in terms of, solving this challenge in a practical, technical terms, there are some frameworks and tools like Istio that are coming. To be honest, that's the maybe only one that I know, apart from maybe tools like New Relic or similar, where you add some library into your application and it will gather everything over the time. So maybe just in that area of like New Relic, Istio, what are some other options that we have?
So New Relic is an APM, right? Application Performance Monitoring. And Istio is nothing like that. Istio is, it's a service mesh, right? And then there's tracing, right? Tracing is incredibly important if you're using like microservices, because ordering is so important. And so there's two things here. First of all, I see observability as sitting like right smack in the middle of monitoring and metrics, logs, and APM. Like it is honestly, I believe in the next couple of years, you're going to see all three of those categories go away, because they were all premature optimizations based on the premise that hardware was very expensive. So they had to like optimize for something up front when the data is being written out. What you want is to not have to write that data out to three different places, because then you as a human are sitting there in the middle, copy pasting IDs from tool to tool, trying to track down a single problem. That's just nuts. It's expensive. It's unwieldy. It relies on humans. Like it's not. You want there to be one source of truth, and you want to be able to go from a very high level, like the dashboards that monitoring has, to a very low level of like the logs, right? Without jumping between tools. So I think that observability is ultimately going to make all of those categories disappear or become one. So that's the APM. I think you're absolutely right in that tools of the future will have to come from your code. You're going to need to install a library or something, and you're going to need to do some amount of manual effort. Not zero, because magic is never going to give you insights into your code. Like, you know your code. I don't know your code. I can do a lot of guessing, and that's going to get you a long way. It's going to get you your great top 10 graphs, which is what New Relic gets you, right? Those beautiful top 10 graphs. But then you hit a wall. You're like, okay, cool. I care about this graph, but for this user. And you can't do it, right? So the Honeycomb way, and I think that this is becoming kind of the industry standard way, which I'm stoked about, is when the request enters a service, we initialize an empty, arbitrarily wide row. structured data, right? And then we pre-populate it with everything that we know about that request or could infer from the environment, from the language internals, any request parameters that were handed in, everything that we know. And then throughout the life of that request in that service, you as a developer can basically do printf of anything that you think you know are going to be interesting. Shopping cart IDs, user IDs, anything that you're like, this is going to be useful to me for debugging in the future, you just stash it into that blob. And then at the end, when it's ready to exit or error, it ships off to Honeycomb as one single, very wide, usually hundreds of dimensions, right? Structured data blob. And then if you have like 12 microservices, you're going to have like one of those blobs for the edge, one per service, and maybe one for each database call, right? And that gives you a really powerful amount of context. So when you're debugging these systems, it turns out that the hardest part is almost never debugging the code. It's figuring out which part of the system the code that you need to debug lives in, right? And if you have this rich context for the entire path of your request, it allows you to zero in and pinpoint that just immediately, right? If you're looking for, and you have so much context, letting you serve up outliers, or say like which 5 things have to go wrong in order for this spike of errors to happen, right? You've got all the data packaged in the right way for you to get that really rapid wisdom out of it. And it turns out that since tracing is so important, well, if traces are just events with some ordering, right? So you basically can get that for free if you're, like the Honeycomb library basically does this for free. Like if you're using the Honeycomb library, you get all of the, span IDs and everything emitted so that you just switch visualizations. You're slicing and dicing, trying to isolate an error. Oh, I found it. Cool. Let me trace it. Oh, there's the problem in the trace. Okay, now let me zoom out and see who else is impacted by this. Again, so you've gotten away from that thing where you're storing it in 4 different places and the human is hopping between tools. When it's just one tool, it just gives you observability and traces are included. But it really does start with that library that you build into your code that gives you the insights from the inside out, right? You've got the software explaining itself back out to you, the developer. And then once you've found, where in the system the problem is, then you can go like debugging, like GDB, like stepping through functions is out of scope for this kind of thing, way out of scope. But it tells you where the problem is happening, and you have all of the context of the request at that point, so you can feed that into your local debugger and find the actual problem.
Okay, and so when you said the request is coming in, so and then we have something which is on the application level. So
which is on the what level?
You have something which is on the level of the process which is running in whatever programming language. So can those two talk together? So that request which is coming in, which is just request, give me sign in page, and then those can be combined. Generally, the request which is coming in until it gets out, you everything put in that single blob.
Yeah, it's just a library in your code, right? We provide all the helpers. And other people have done this, like not using Honeycomb. They've implemented the same thing where they initialize an empty data blob at the beginning, they pre-populate it, then they stuff stuff in through the life of the requested service, and then they fire it off. And this is just the where in your system problems are, like full stop, that we have discovered as an industry.
Okay, yeah, that sounds very powerful. What you said, I can totally relate to that. There are 5 tools. There is PagerDuty call coming in.
I know.
You open 5 tabs and look.
And you have to pay to store it, so many times. It's not a good use of money either. And I'm a big believer I believe that observability should be a dollar well spent. I think that it should generally be like 10 to 30% of your infra costs. You should spend that much on observability, but not on every single tool, like total, right? So you really want something that can bundle up as many functions as possible. And and right now you've got all of these people who are charging you like they're your only tool, but in fact you need all these different tools, and it's kind of painful. But I believe that the industry is headed in the right direction.
Yeah. I can share a board story that I'm sharing every second episode. And that's when the first version of Semaphore was a Rails monolithic Rails application. At the end, it was like close to 100,000 lines of code, and lots of memory and all that. And when we creating the second version, we use the Elixir as our main language, and we have somewhere roughly like 20 services running. And we were getting close to, we are going to launch. And we used Kubernetes in production for the first time.
Mm-hmm.
And we delayed our launch by maybe a month and a half. at least, until we installed and learned to use Istio, in our Kubernetes
Yeah,
cluster.
yeah, yep,
So it's probably possible to use, Kubernetes without Istio, but I would rather
yeah,
not.
yeah. Agree.
Yeah. And
Yeah,
yeah, the other thing that you mentioned that I wanted to ask, I'm interested what you think are the main things that influences that. So the same example that I have. So for instance, the monolithic application that we have, it was
yeah,
there was a relatively sharp edge, sharp line between who when it's not working, when it's not booting, or where
yeah,
request queue is full,
yes,
who is going
yes,
to tackle that. And you have that code base of all the
yeah,
features are there, so any of those can make a problem.
right,
It was very much it was clear that who is on call, and there was a group of people, and there was other group of people which was just not on the call. And one thing that was
yeah,
maybe not surprising, it's probably understandable. So developer that is developing a service, application, at the end it's just an open operating system process, and pretty much
yeah,
engineers have no clue, does it require 4 vCPUs, 8? Is
yeah,
our application 16 gigabytes of RAM or
yeah,
4? Like,
yeah.
no
Who
clue.
knows? Yeah,
And
yeah,
now with Kubernetes and containers and all that, you pretty much you have to reserve your capacity. You have to watch the
yes, you do.
yeah. So I mean, at least in my view, my view of the world right now, I mean that's the main thing that influenced this. That every developer is
Yeah.
kind of system reliability engineer.
The abstraction has gotten very leaky, right? Like now you have to care about those things. You have to think about them or you're just going to be screwed. Absolutely agree. I think that, and I think that part of the reason it's taken us this long to agree that software engineers should be on call is because in the past we've asked them to be on call and then we've given them ops tools to debug their code with. And like ops tools speak the language of, this amount of memory is free, this type of memory, this uptime, this, and like translating that to the world of variables and endpoints is just like, it's a different world and it's a different language. And you were basically asking them to do two jobs, right? Do your job, also learn this other job and do it at the same time. And it's just like some exceptional engineers did it and do it well. Most engineers, and I don't blame them, were just like, hell no, right? Which is why Honeycomb is very much designed to speak to engineers in the language of variables, endpoints, and the things that they spend every day thinking about. But it's definitely true that like I was saying, second wave of DevOps is kind of like saying software engineers. Ops is now part of your job, right? And I would argue that that's a good thing because ops has always been the engineering org most aligned with user happiness. It can be very easy for software engineers to construct an ivory tower where they don't feel the pain or the consequences of what they've shipped. That tower is being torn down. It's going away. And I think that this is overall a very good thing. But there's definitely some pain in the meantime. You were talking about, what was the thing I wanted to mention? You were talking about, oh, I've lost the thought. Yeah, no, I agree. Software engineers, the abstraction, the level, it's bouncing around a bit, right? It's like you need to learn some ops stuff, but at the same time, more ops stuff than ever is abstracted behind an API. Like the most of the operations done for Honeycomb is done by AWS ops engineers. Like it's not done by me. I don't have to think about CPUs anymore, except insofar as like provisioning them as some abstract quantity for my application to run on, and everyone wins, right? Because that's a very clear line of abstraction. Oh, you mentioned developers on call and like the lines between roles. Yeah, this is a very hard problem. If you've got a monolith and you've got 20 developers, you can't have a rotation with 20 people on call. That rotation is so long that everyone's on call like twice a year. They're going to forget everything in between those times, right? There is a link that I posted last night of Molly, I forget her last name, but she posted this case study, which is great, of how they took a monolith and 3 teams of software engineers with 3 SREs supporting them, and they divided up the types of alerts into various, and they're like, okay, I own these, you own these. And it being a monolith, there's kind of no way to protect each other from, you're all going to get the top level of alerts of the app isn't performing well, but like I'm going to take the Elasticsearch ones, you're going to take the Mongo ones, they're going to take the MySQL ones, right? And that kind of works. It kind of works because you got 3 people on call at any given time. They're buddies frictions of like 7 people each, and that's doable, right? But most people are starting to look at the shift to microservices now, and microservices give you more tools for doing on-call differently, right? If you've done it correctly, you'll have a service in front of every data store. Data stores are the number one cause of infection, right? Of seeping throughout the layers, because if a data store goes down, everything starts queuing up waiting for that data store, everybody's getting paged, right? Which is why you have to take that and put it in a service that's a level up and make it so that only the people who are responsible for that data store get paged. And you can start to separate out who's responsible for the app, who's responsible for the data store. And, you can start to group up if you've done it Uber style and you have like a shit ton of tiny little services, you can start to group up like, okay, this team is going to own these 4 or 5 services, right? I feel like a upper limit of like 1 to 2 services per team member is the absolute max. And really that's talking like, 2 or 3 in active development, and the rest have to be pretty stable if you're going to go beyond that. And it's definitely possible to take the philosophy a little too far, but I think all in all, it is the right direction for us to be taking steps in, and learning how to isolate these services cleanly from each other so that we can craft on-call policies that only impact the people. Because the key to designing an on-call rotation that doesn't burn people out and that is effective is making sure that every single alert that you get is actionable, that you can fix and make it so that it never happens again, right? Because every time you get paged, you should be going, this is new. I don't understand this, right? It's the death of on-call if you're like, oh, that again. Oh, that again. That will kill your team, right? You have to pay that down. And if it's, oh, that again, and I can't fix it because it's somebody else's problem, that is 10 times worse. Like that will burn people out like nothing.
Yeah, I agree completely. Do you have any predictions how this will go out? I mean, there are so many developers in the world that haven't been on call, and I developed this small feature, shipped it, not something that I'm going to worry about.
This is it's a cycle, right? And I feel like there's an understandable period where people are just like very repelled by the idea because it's so bad for ops teams for so long. Do the work of climbing out of that pit and talking about it and telling people, no, a better world is possible. And it is possible. Like I've seen teams who never get into that pit. Like my teams, we consider it a crisis if someone gets woken up, and we post-mortem it and we make it so it doesn't happen again. We respect their time and their sleep. I've also seen teams who are way deep in the pits of like terribleness and they've clawed their way out and it's been better. Because the amazing thing is that once you get out of that hole, you have so many more cycles to think about what's best for your users, and you can spend your time more efficiently. Like firefighting is just like lost time of your life. So I feel like there are three pegs to this stool, right? There is ops teams, like we have to like stop being gatekeepers. We have to stop blocking people. We have to stop building a glass castle. We have to start building a playground. This is why I say test and prod. We have to get used to being like up to our elbows. Every engineer who's shipping to prod should be looking at prod every single day, so they know what feels normal and they know what wrong feels like, and they know how to debug it. And they know how to get to a known good state. Like that's like the bar of operations that every developer who's shipping to prod should have, right? Everyone should know how to debug, how to get to a known good state, and how to deploy. So ops people need to stop being gatekeepers, and we need to start inviting people in. We need to start sharing our knowledge and educating, and stop seeing ourselves as the people who do things and start seeing ourselves as the people who empower people to do things, right? And I'm setting aside infrastructure engineering because infrastructure engineering also has software engineers and ops people who, but that's a level of abstraction we're not talking about, right? And software engineers need to be like willing to be hurt again, take a risk on love, right? I know you've been hurt before, but I swear to you, you'll get hooked on it. The dopamine hit of just like, oh, I found it, I fixed it, I made it better for that user, and you're seeing the impact of your work, that is addictive. And that once you've, like, what I've seen is that once people have experienced that level of control and power and empathy with their users, they find it very hard to go back. They don't want to go back to a place where they're insulated from it ever again, because it's so much more visceral and real, and they can see the impact of what they're doing, and that's very motivating to every engineer that I know of, right? So scarred and like who have been woken up so many times, they're just like never again. Like, just please, you have to be willing to try again. Like, you have to, because it's up to you too. Like, we need you and the original intent in your head to help us dig ourselves out of this pit. So the third part is management. There's no on-call situation that will ever work if management is not carving out enough project development time, like contiguous development time, for things to actually get fixed. And I know that interferes with product, shipping cycles in the short run. And you just have to get aggressive about it. You have to shield your team. You have to carve out that time, let themselves dig that out of that hole, so that you'll have so many more cycles freed up to spend on product, and so many fewer cycles going down the toilet to debugging like production problems in prod. But like, this is the job for line managers, like, because it is not reasonable for you to expect your team to be on call if you are not carving out the time, the political will, everything. If you're not carving out the time for them to fix their shit, then you're just asking them to like go to the salt mines like every day. And if any engineers are working under those conditions, I would encourage them to quit their jobs and to go to somewhere where they do have air cover, because it takes all three. But it's doable, and it's a better world.
Yeah. You presented this very nicely, and I agree with you that it's a better future that it will bring.
And you need observability.
Yeah.
Because otherwise, like, all along the way, if you can't see and be confident in what you're seeing, if you can't ask questions, if you can't break down and make sure that this new build ID next to the old build ID and see exactly what the impact of your changes are, then you're just shipping blind, right? And you'll get there, but it will be long and arduous and painful, and you'll lose people along the way. If you can see what you're doing, everything is better.
Yeah, true. This was a fantastic conversation around all these topics. And maybe as a last thing, I wanted to ask, what are some features that you're planning to ship in Honeycomb that you're most excited about?
Oh boy, yes. So two things. We're shipping. We have in beta now a tool for SLOs. When I was talking about being able to go to the big picture, like what's happening at big level, down to into the weeds and see individual requests. A lot of people get stuck on the question of how much is too much, or like management is very concerned about this one user, and engineers are like, it doesn't matter. And you need to have some common language there where you all agree this is what matters. And below this line, engineers are responsible for delivering. And above this line, managers are responsible for making sure that it's the right line, right? And that is what SLOs are. SLOs are service level objectives. You have a few service level indicators where you all agree this is the quality of service that you agree to provide for your users. And as long as you are hitting that line, like anything that you do in engineering is fine, right? Solve it as you want. This is how we create that crisp level of abstraction, right? So that everyone gets what they need and nobody feels micromanaged and nobody feels completely abandoned, right? You agree on this number, and then engineering can like go and build it however they need to. And SLOs, like, that sounds deceptively simple. It is not. It is actually, as everyone who's tried to open this Pandora's box knows, it quickly devolves into arguments about, well, what does good actually mean, and over what window of time, and it's infinite, like it's a fractal level of questions. So we're building this into Honeycomb so that you can just pick, any query that you run, you can say this is a serverless, this is an SLI, this is something I care about. And then out of your SLIs, we will compute, this is your SLO. And so you can see if you're hitting it or not, or if you're on track to run out of your budget before your time is up. Or, and this is the most powerful tool that you could have in your arsenal for allocating time correctly. Like when I was saying that managers have to carve out the time for their engineers to fix things, how much? How good is good enough? Engineers are always going to want to like spend time, refactoring, making things better, more elegant. How much is enough? That's where SLOs come in. SLOs are the number that you have agreed upon. And so if you're on track, if the quality of service has been really bumpy for the past, 30 days and you're running out of budget, that's what your manager uses as the hammer to be like, okay, sorry, product development roadmap stops. My team needs time to fix things, right? And when things are going pretty well, and engineers are agitating because they really want to, do this thing that, isn't directly tied to product development. That's when managers can go, you're going to have to wait for that, team, because actually we're meeting our objectives, and it's time for us to make progress in the roadmap. This is the only way that I know of to make this relationship not fraught and painful, right? You agree on the number, you ship it, you build to it, you're done. So nobody in the industry has actually done this well yet. Everybody and their aunt has released calling SLOs. Liz Fung-Jones just joined our team a month or two ago from Google, and she got SLOs there. So she has been leading the product development process for us, and we're building an SLO product that I would be proud to run myself in production, and we're documenting it, but it does it correctly, and I think that people are going to be really stoked. The second thing that we're building that I'll say a little bit less about is there's this myth in this industry that you can not throw away data. The log vendors who are like, keep every log line, and the metrics vendors who are like, we keep every, bullshit. Either you're throwing away data at ingestion time by aggregating, or you're throwing away data after that by sampling. There is no other way. No company in this world is going to pay for an observability stack that is as large or larger than their production stack. It's just not going to happen. And we've kind of lost the muscles and the language because our vendors have been monopolizing this conversation, and they've been mostly the pre-aggregate types, plus some logging vendors. We want to reintroduce sampling, and we want to do it in a way that helps elevate the level of discourse and speaks to people like they're engineers. This is not outside of your scope to comprehend why sampling matters, right? It's just that it's, we don't have the libraries, we don't have the language, we don't have the, so we're really, we obviously are a tool where if you don't sample at some level, it's going to be absolutely unaffordable. But that's fine, because what percentage of the 200s to your root domain do you actually care about? Almost none. You care about trends, you care about errors and outliers. All of this can be done incredibly cost effectively with intelligent sampling that weights, common things like 200s as less important than things like 500s. So this is not a hard product to develop from an engineering perspective. Difficult thing to develop from a language and marketing and educational perspective. And it's 3 years in the making. So I'm really pretty excited about it.
Okay. So a question, what's the ETA?
SLOs are being beta tested right now by some customers, and if anyone wants to try it, they should hit us up. The sampling stuff, maybe a month. We're a startup, we move pretty fast when we decide to do something. It's pretty great.
Yeah. When I heard 3 years, it felt kind of natural to ask, what's the ETA now?
It's time. It's time.
Great.
Yeah, totally.
Great. So sounds all very, very exciting.
Thanks for having me on. This has been really fun.
Yeah. For me also, I learned a lot, and it was great to hear about your process of thinking and how you're seeing the infrastructure ops and everything that is right now and where it's going. And it looks very promising to me.
Thanks.
Thank you very much. See you. Bye.
Bye.